Hi, this is Abdul and Andrea of Group 29, and this is our FPGA project. Andrea's going to start by explaining the overall CPU.
Yeah, so the CPU is a 32-bit register, points to the instructions, and the ROM holds the instructions and passes to the control unit. Control unit takes the instructions and decides which opcode and functions to use. And the functions tells which switches to control. For example, if you get a jump, it's set to 1 and come back to the multiplexer. And the multiplexer tells the program counter to point to another instructions. And if you get an opcode, it gives the instruction to the ALU, and ALU do the stuff like addition and subtractions. Also, ALU gives the output to the data memory, which holds the instructions temporarily, and gives the instructions to the display drivers, which displays the 7-segment display on FPGA. Also, the register file hosts register and control values, and it gives the values to the ALU. Finally, the ROM also gives some instructions to the sign extent, which turns 16-bit instructions to 32 bits, and finally passes to left shift. And between the program counter and the ROM, the adder increments instructions and passes back to the program counter. And now my partner will talk about the adder.
Okay, so at the very basic level, if we think about two input bits, they will either carry if they propagate or generate. Now they're going to propagate if either of them is 1. Propagate means that they're going to carry with the carry bit included. They're going to generate if they're both 1. Generate means that they're going to carry without the carry bit included. So if we know if 2 bits are going to carry or propagate, we can work out the final propagation. So if we give two inputs to a propagate generate, then we know if these 2 inputs are going to carry. We can pass that into a look ahead unit, which then tells us what the final carry bit is going to be. The look ahead unit is this one. So this takes in the propagate and generate and basically outputs whether it's going to carry or not. This right here is actually a 4-bit carry look ahead adder with the look ahead unit included. We use the XOR to add the carry bits with the sum. And then to actually make the actual adder itself, you take the 4-bit carry look ahead adders and you use a ripple carry on them. That's what these little lines are doing. They're feeding the carries into each respective one. And then your final sum comes out from here. And that's it. Okay, so to make the squaring program, we started by making it in Python to understand the logic. Basically, it takes 3 inputs, x, y, and a counter, and it keeps incrementing this y variable until the counter is the same as the initial input. So for example, if you put in 7, it's going to keep adding 7 to y until the counter is 7. So in terms of assembly, what I've done is I've said X is my T0 register, the counter is my T1 register, and my Y is my T2 register, and I've just translated that directly into Mars. So this starts by initializing the variables, T0 to 1, T1 to 0, T2 to 0. Then the square function is called, which does the Y equals X plus Y line. This increments the counter, it's the same as counter plus plus. Then this says, okay, if we reach that if statement where the X and counter variables are the same, go to update. This updates the 7-segment display, and this essentially resets it back to the next value, basically. So then we can square it again and keep doing that pretty much forever.